Hello everybody. In this video I will solve two problems and that will hopefully answer all the questions that I got in my email. Okay, so the only questions that I got were about constructing confidence intervals and hypothesis testing. So the first one is about constructing a confidence interval. So let's see what we have going on here. A recent Gallup poll asked 1,006 people during the past year about how many books, either hardcover or paperback, did you read either all or parts of the way through. And then we have the following results. So let me go ahead and start writing what we have. So a sample of 1,006 people produced the following. We have a sample mean of 13.4 books with a sample standard deviation of 16.6. Okay, so what's the big idea here? We want to take this information and use it to come up with a conclusion about all Americans, right? So we kind of want to say that, yeah, right, X bar is approximately the population mean, meaning that all Americans read about 13 books on average, right? But that's your point estimate. We want to do a little bit more than that. We want to give it a range, so that plus or minus how many books, right? So that's what the confidence interval is. It's given that margin of error, so given a little bit more than just 13.4. So how do I know which command to use? And that's a question that I get asked all the time. Which one do I use? Well, it depends on the standard deviation. You're always given some sort of standard deviation. If it's sample standard deviation, then we will be using T interval. Okay? S stands for sample standard deviation. If you were given sigma, which is population standard deviation, then you would be using Z interval. It is that simple, and it's right there in the problem. Okay, so here I have S is equal to 16.6, or it will say sample standard deviation. Okay, so now we need to use T interval to construct the confidence interval and then write interpretation for it. So let me go here. I'm gonna go to, gotta turn it on. Okay, we go to stat, test, T interval is command 8. Okay, I already have all my data plugged in. The sample mean is 13.4. Standard deviation is 16.6. Sample size is 1,006 people. That's a pretty large sample size, so we should be able to come up with a really good inference. 99% is the confidence level. Let's calculate it. What do we get? Okay, so we get this confidence interval right here. Now, since we're talking about books, it would make sense to round it up to a whole number, right? So, okay, so let's say between 12 and 15 books. So you can write, so let's say 12.05, right? So your actual confidence interval 12.05, and what was the other one? 14.75, right? So let's go ahead and write a conclusion. Conclusion. We are 99% confident that the interval, let's say 12 to 15 books, contains the true or the actual population mean number of books read per year by all Americans. And this is crucial, by all Americans, not just those 1,006, We know what their average is. Their average is 13.4. But this statement right here tells you that the true mean number of books read by all Americans is contained in this interval right here. Okay? And we're 99% confident that that's true. All right? So for confidence interval, what's the big idea here? The big idea is to come up with this range of values that cover the true population mean or population proportion with certain level of confidence, right? So in this case, it's 99% confidence level. Okay? And again, what's the trick for trying to figure out which command to use? Well, here's the trick. You either use standard deviation or population standard deviation z interval, sample standard deviation t interval. If the problem is about proportion, then there's only one thing to do. It's one proportion z interval. Okay? So if you go back here, let me just show you where all these commands are. Stat, test. If you go down here, so z interval, if your population standard deviation is given. T interval, if sample standard deviation is given. And then we have one proportion z interval, this one right here. That is if your problem is dealing with proportions. Okay? Okay, so that's that. Let's go ahead and take a look at the next problem. This problem right here is a hypothesis testing, and I will be talking here about proportion. Okay, so let's see what's going on. Okay, we have that in December 2011, the statistics that was collected for adults with children under the age of 18, it was 38% of adults said that they have family dinner 7 nights a week. Okay, so this is the statement that's accepted to be true. Okay, that's your true statement. That's the collection, that's the information that's been collected, and we take it as a default statement. Okay. Now, in the recent poll, we have the following information: 403 out of 1,122 adults with children under the age of 18 said that they ate dinner together 7 nights a week. Okay. Just to kind of give you an idea what's going on here. In 2011, we had this proportion. Now we have, let's just see, 403 out of 1122. Let's do times 100. That's about 36%, right? So 35.9. Is it smaller than 38%? Absolutely. Is it significantly smaller? Well, that's what hypothesis testing is all about. We're going to figure it out if this proportion is smaller by a significant amount. Okay? So, let's see what we have here. 403 out of 1,122 adults said that they ate dinner 7 nights a week. Has the proportion of families with children under the age of 18 who eat dinner together 7 nights a week decreased? Decreased. Okay? The first step is to set up the null and the alternative hypothesis. Now, my problem is dealing with categorical data. Categorical. It's the proportion of all families that eat dinner every night. If it's categorical, that's proportion. So my null hypothesis will say P is equal to 0.38. This statement right here does not need to be proven. It's true. We take it by default, okay? Versus the alternative. The alternative is always in the statement. Has the proportion of families with children under the age of 18 who eat dinner together 7 nights a week decreased? Well, has it? Well, let's find out. P is less than 0.38. Okay, what is our P hat? This is our sample proportion. We've computed it to be about 0.359. Is it smaller than 38%? Yes, it is. But is it smaller enough? Okay, Well, there's only one command that we can use. It's one proportion z-test. So we go here, statistics, test, one proportion z-test is command number 5. Okay, what's the null? The first line is the null hypothesis. So here we say 0.38. X, this is the number of people that said they ate dinner every day of the week. So that's 403. N is the sample size. And then this is my alternative hypothesis. I need to highlight correct inequality. So that's P is less than P naught, which is 0.38, right? Okay, so P naught is that. So let's calculate. And the P value that we get is 0.0754. P value 0.0754. Let me just check. Okay, so here's your proportion, right? So this is your P hat, this is your P value, 0.0754. What do we do with this? Okay, well, this tells you really what's the probability of taking this sample and computing this proportion and getting it to be 0.359. Well, it's 0.0754. We got to compare this to the alpha level. So 0.0754 is greater than 0.05. Think about this way. This would be unusual, right? We say that 5% chance it's unusual. If this is greater than this, then this is not very unusual. So that means this evidence is not very strong. Yes, 0.359 is less than 0.38, but it's not significantly less. Okay? That means what? What's the conclusion? Here's your conclusion. We fail to reject. Fail to reject H naught. We do not reject H naught. Okay? Because the evidence is not sufficient. There's insufficient evidence. There is insufficient evidence to claim that, to claim what? To claim that the proportion of families with children under the age of 18 who eat dinner together 7 nights a week decrease. So you can just copy that statement, that the proportion of families with children under 18 who eat dinner together 7 nights per week has decreased. What does it say? Well, it means that it has not decreased, right? Okay, so it did not go down. The sample gives us sample proportion of 0.359, but it's not significantly different. That's what this means. Okay, so for hypothesis testing, how do we deal with this? Okay, if let's do p-value small, right? P-value is small. What do I mean by that? P-value is small. It's less than alpha level. That means the evidence is strong. Strong evidence against H naught. Okay, we reject the null hypothesis. That means we have a situation where our sample is so different from the statement that's already accepted to be true that H naught must be false. Okay, so strong evidence against H naught. If the p-value is p-value, I'm writing this sloppy, right? So p-value is large. What does that mean? Greater than alpha level. we don't have enough evidence. So this would be do not reject H naught, right? So do not reject H naught. This one is reject H naught. Okay? All right, I think that should be it. If you guys have any other questions, do not hesitate to ask me. Okay?